Hello everyone, my name is olyyan, and today I will be presenting on LiDAR technology. Let's dive into it. So what is LiDAR and what is some of its applications? LiDAR stands for light detection and ranging. It can be defined as a remote sensing technology, which is a device that uses laser pulses to measure distances and create a 3D map of its surroundings. As we can see in the image, some of the widely used applications, which is used in autonomous cars and used in drone surveying and used in environmental mapping. In this slide, we can see some of the LiDAR key components. The LiDAR system is made up of several key components. These includes the laser source, as we can see, and the scanner that directs the beam, and the receiver that detects the return signal. It also relies on a GPS for precise location and an IMU, which is a motion sensor to track the tilt movement. And in this slide, we can see the working principle. As we can watch this cool animation, we can see the laser sending out pulses of light. Each pulse travels out, then it hits the object, then it bounces back to be detected by the sensor. So the key measurement here is the time that takes to travel a round trip. Since the speed of light is constant, we can calculate the distance using the formula speed of light multiplied by time and then divided by 2. When this process repeats millions of times per second, it creates a detailed 3D map. And to tie this to our class, when we learn about Gaussian beam, so Gaussian beam and LiDAR, looking at this figure, we can see how laser beam intensity distributed. The beam is strongest at the center and gradually fades towards the edges, following a bell curve. So this pattern mathematically described by the Gaussian formula that is shown, I of r is proportional to the power of negative 2r squared divided by w squared. In simple terms, this means that the beam intensity drops off exponentially as we move away from the center. And understanding this beam shape help engineers predict how laser will spread over a distance and which directly affect the LiDAR's resolution and effective range. And finally, the advantages and limitations. LiDAR technology delivers high accuracy and it works despite the lighting conditions, whether it's day or night, and it scans very large areas. That's one of the great advantages. However, some of its performance drops during extreme and bad weather due to signal scattering, and also the range gets limited. And finally, despite the issues with LiDAR, it remains a crucial and powerful tool for modern mapping. Thank you. This concludes my presentation.